No.
How we doing?
I'm straight. Yo.
All right. Give everybody a minute to get in.
No.
Mr. Dean, I have a question.
Yes.
For our math homework that we do, like all those, you can submit them at the end of the year, right?
Repeat your question.
For all our math homework that we be doing on WebAssign, you gonna put the grades in for those at the end of the year, at the end of the semester,
What do you mean put the grades in?
in the grade book, or they don't go in the grade book?
They go in the grade book on like.
Oh, so it's not like an actual thing in our like e-learning.
No. So those two things aren't linked together. So like I can't, there's not an easy way to take everything from WebAssign and put it into
e-learning.
Yeah, e-learning, because they're not connected. So there's not an official grade book for e-learning. No. Good question.
So we're going to determine like what we pass or not.
How you do? I guess I don't understand that question. Like
they really trying to say, do the homework assignments count to our like overall grade at the end?
Yeah. So you can see all that. Let's see. So right now I'm in your e-learning thing. And if you go to syllabus and so the grade breakdown is in the syllabus. You want to calculate it yourself. The homework all gets averaged together and it's worth 20%. Quizzes 15, attendance participation 10%. Each test you take is 10%, and the final is 10. So that's what the breakdown looks like, but there's not a live updating calculator for your grades. But you should be getting back everything for your tests and quizzes, basically if you were there or not, kind of thing. So that's the breakdown, but the homeworks absolutely will be included. But there's no way to simply put it into your grade book in MyAllen. There's no like link between WebAssign, but you can view your scores in WebAssign. But good questions. So kind of with that, we'll do a brief rehash update. So if you go on your e-learning and resources, last time we went over the moving online documents, and I also posted that to YouTube. So if you would like, you can go review that if you missed it for some reason. So the reviews are going to get posted up here, but I've also gone ahead and posted the lessons. So if you open up that folder, it will look like this. And so this is all of the posted notes that I go over. So today we're doing, I think, 7.5 and then 7.6, but it's got all of the notes that we're going to be going over the rest of the semester, pretty much. So yeah, so we've got interest coming up. And if you want to see the breakdown of that, it is also in the syllabus. So we are finishing up with 7.5 and 7.6 on Friday, and the tests will be up next week. So yeah, I will, when I do the review, I will go over the test setup a little bit more in depth, but for now, we will just continue on with our interest stuff. So I guess I can do a quick rehash of the other one. The last time we've been talking about interest and how to calculate it, and we were going over credit card interest and how this idea of the APR works, where it's an annual rate, but they divide it by 12 because it gets established monthly. Actually, let's look at. All right. So this is our base interest equation. Interest paid equals PRT. And this is what we've been using to apply in all of these different scenarios. So with credit cards, the one big thing was we have different ways of calculating the principal. So we had the previous balance method, adjusted balance, average daily balance, all of these different methods. So now we'll be moving on to compound interest. So compound interest happens when interest gets paid on interest. So if you have a credit card and you have $1,000 on it, and you had 10%, then the next month you have $1,100 balance on it if you didn't pay the interest. Well, that stacks up. So when they calculate your interest for the next month, it takes 10% of that 1,100, which is 110. So you're paying even more in interest every time. So, for example, if an account is compounded yearly at 8%, what will be the balance of a principal of $1,000 after 3 years? So, let's do the thing again. So, what would be our interest payments? Sorry, I'm a little all over the place. I'm having to take over my one of the rooms in my house. It's usually my kids' playroom. So. So we start off with our relationship. I equals P R T. All right. So in this example, sorry, getting my stuff pulled back up. In this example, we had $1,000 is our interest rate, and make sure we're good. Okay. So principal is 1,000.
Hold on, Dr. Dean, can you read that formula out real quick? It's
Get out.
R
PRT. Principal, rate, and time.
Okay, thank you.
Yep. So the first round, the first thing we'll try is simple. And we've calculated it up to now. So our rate is 8%. And time, all right, jumped ahead of myself. Rate is 8% and 3 years. So multiply this out, we get 240. This is how interest has been calculated up to now. But we're doing compound. So this gets added every individual year. So at the end of year one, we have $1,000 times 0.08 times 1 year. Well, this gives us $80. Okay. So that gets compounded, or that gets added into the next year. So year number 2, our principal is $10,000. 80 times 0.081. And this is
80 again.
it's not quite 80. This is, let's see if maybe that'll be.
I think you need to get a black marker.
Yeah, I had one and then it disappeared on me. Where did flash go? All right. So I'll change the one that's new.
Thank you.
We had to take that $80 and add it to our principal.
Okay, I didn't see that. I'm sorry.
And that's, again, that's not your fault. That marker was definitely on its last leg.
Mhm.
So it's 1,080.
Okay.
Which, when that gets used, we end up with
Hold on, wait, I did that wrong. 1,080.
86.40. So that gets put back into the previous.
Wait, what you said the answer was?
I'm sorry?
What did you say the answer was?
So the interest paid for that year is 86.40.
Okay, I was making sure we got the same answer. All right.
Oh, I'll start using the black marker now. So for the third year, now we have to add that 86.40 to this one, and we get 1,166 times 0.08 times 1. Let's see. Looks a little bit better, but I probably need to write a little bigger. Yeah. So all right. So the interest on that,
It's like $93.
do what?
It's like $93, right?
Yeah.
Some change.
So 1,166. Yeah. The interest paid then is 93.31. So in total, we paid a lot more. We paid $259.71 is the total interest paid, which is more than 240. So this is the idea of compound, where you can take the same interest rate and the same principal, but if you compound it every year, because every time you compound it, it adds a little bit more, a little bit more, a little bit more. So we can kind of simplify this process of compounding a little bit. Because every time we did a step, we took that interest and added it back in to whatever we started with. So what this does is it changes each of these steps. If we don't want to just find the individual interest, we want to find what's going on, including the principal. you get 1,000 times 1 plus the rate. Right? So, sorry, plus RT. In this case, RT was that 0.08 times 3 thing. So this is how we compound it.
So what's the difference between what we're doing now and what we just did?
Okay, so what we're doing now is we're trying to kind of combine all of these steps into a simpler one.
Okay.
So every time we multiplied it together, we did this. But then we multiplied it by that again. And then we multiplied it by that again and again.
Yeah.
So after the first year, it looks like this. After the second year, it's like this. After the third year,
okay.
So what do we call it when we're multiplying by the same thing every time?
Yikes, that's a good question.
So let's say this wasn't 1 plus RT. Let's say this was just X.
Mm-hmm.
X. Is there a simpler way to write that?
Hey, Dr. Dean.
Square, or cubic.
We've got some people in the waiting room.
All right.
All right.
Hey,
So what
Dr.
if we
Dean.
create?
Brenda said, can you let her back in the class?
Yeah, I did. Yeah, sorry, I'm on the other side of the room from my computer, so it's tough to notice when people pop up in the waiting room.
So like x cubed?
Yeah, so this is X cubed.
Yeah.
So something else kind of happens when we do this is the time for each individual one was 1 year, but we want to expand this idea out to 10 years, 20 years, 30 years. So this actually becomes T over, we're going to call it N, which is the number of years.
So time becomes time over numbers?
Time over number of years. And the number of these things that we have becomes the number of years. So it's okay if this, what I'm doing right now, doesn't quite make sense. It's a little beyond the scope, and it's not something that we're going to test you on, but for those who want to know where this stuff comes from, instead of me just throwing up an equation and being like, yeah, deal with it. Usually like to, give some background. So the number of these things, because it's an annual thing, is just however many years we did this over. So if there was 2 of them, then that's squared. There's 3 of them, cubed, 4 of them, whatever. But you can simplify all of this stuff down into principal times 1 plus R T over N Sorry. Having to go with my my notes over here because I went ahead and filled most of these out. Okay, so this is where that thing comes from. This is our compound interest formula. So if you don't care exactly where it comes from, that's fine, like I said. But we have our normal players. P is still principal, R is still rate, and T is still the time. So it could be 6 months, it could be 10 years, doesn't matter. But we have this new thing, N. It's the number of times. It's gonna be fun. So this is, N is the number of times that this thing gets compounded per year. All right. So sometimes.
So that would in this predicament be 3, right?
No.
Okay.
This, in the one that we were doing, T is the year.
Okay.
I'm sorry, the time. Okay, 3 is the time. Sorry, little awkward. So we still have our normal things: P, R, and T. N is how many times per year does it get compounded? And in this case, it got compounded one time at the end of every year. So when we did that little breakdown, I'm really missing my smart board right now because I wish I could just pop back and say, hey, remember that? So N is how often it is compounded per year.
So NT would be 1 times 3.
I'm sorry?
NT would be 1 times 3.
Yes.
Yeah.
Yeah. It's
okay.
compounded once per year times 3.
The amount of
this would be R over 1.
And that R would be 8%.
Yes. Yeah. 0.0.
Over 1.
Yeah.
Okay.
Exactly.
P would be 1,000.
I'm sorry?
P would be 1,000.
Yeah. P in this example was 1,000.
Okay.
So this is the idea. So let's do an example with this. All right. So if an account, no, that's the one we just did. So this is our, like I said, our new equation. A equals P 1 plus R over N in T. So let's do an example with this. Dana invested $3,000 in a special account at her bank at 4.5%. Sorry, having to erase. Compounded monthly. What will be the amount in her account after 4 years? And how much interest did she earn? Okay. So we have our equation. A equals P 1 plus R over N to the N T.
There we go.
All right. So now we have to figure out what are all of these things. So we have P, R, N, and T. Okay. So which one, what is what in this example?
P would equal to 3,000.
Yeah.
Okay.
And
Go ahead.
no, you good. You got it.
Oh, 4.5 is R.
Yeah. So
And
rate is
then
4.5.
4 years would be time.
And
4
then
years.
N will be 12, right?
Yes, you are absolutely correct. N is 12.
Where did you get, oh, because
It said
12
monthly.
Yeah, 12 months. Okay.
Yeah, exactly right. So it is compounded monthly. So it is N is 12.
Get her fucking ass up.
Let's see.
No shit. N was 12, right?
Yeah.
All right.
So now we just plug it in and go.
So
Yeah.
3,000.
3,000
plus 4.5 over 12
plus 0.045
over 12 times 4.
And 12 times. So if you plug that in, you get 3,590.44. So this is how much is in her account at the end of 4 years. So now the question is, how much interest did she pay? Or earn? How much did she make?
Hold on. We add, let me see your screen. That 12 times 4 and then equals to 48. We add that to, after we do like 3,000 and all that.
This is the, I guess, kind of the weird thing is this is an exponential. So this is, what is the other number? So if you simplify this stuff, this is 3,000 times 1.00375 to the 48th power. Can you see that?
Yeah, I see it.
Yeah. So in your calculator, generally you'll do this one first. Do 1.00375 to the 48.
And then
Usually that button if it's a symbol, like in, if you're doing it on an online calculator, that would be 1.00375, and then they do caret 48. So usually that symbol means raised this number multiplied by itself this many times. They also might have a button that says y to the x or something. If you're putting it in
Or
your
X to the Y.
I'm sorry?
Or X to the Y.
Or x to the y, yeah.
Because I'm trying to do it on my iPhone. That's why I asked.
Yeah, I'm not sure what the iPhone calculator looks like, but most phone calculators have that function.
Yeah, damn, that's a big number. I think I did that wrong.
Yeah, so it shouldn't be bigger than it shouldn't be bigger than 2. Really, it shouldn't be bigger than about 1.4.
Okay.
More like 1.2-ish. So remember that there is a period right here. So we're probably going to get cut off here in a minute, because these things have a max time of 40 minutes. So yeah, but I will post my notes, my finished notes of these slides online under class notes,
Okay.
and you guys can review them then. So no quiz today. Sorry, I know everyone's probably pretty upset about that. But
did you get me down for attendance?
I'm sorry?
Did you get me down for attendance?
I have everybody on the list. I have all of your names. So yeah, as long as you're currently logged in, then yes. Yeah. So that's what we're starting, and we will finish up this stuff on Friday. So,
Hold on.
uh-huh.
You ain't erased the board yet, right?
I did not erase the board.
Be
Okay.
quiet,
I did
man.
get it right in. That's why I wanted to make sure. We good.
All right. So remember that this is going to be posted on the YouTube link that I sent. So yeah. Otherwise, I will be at my normal office hours today, and you guys have a good rest of your evening.
Your office hours are what?
All right.
Shout